So I wanted to work through a couple examples of graphing linear inequalities for you, just to refresh your memory. So remember, we're going to get y by itself. So I'm going to start by subtracting the 6x to the other side. So then it's going to be 2y is less than or equal to negative 4 minus 6x. And then I'm going to divide everything by 2. So then we're going to have y is less than or equal to negative 2 minus 3x. And then we're going to graph those and shade. So this is what we solved, and hopefully you realize that the slope on this inequality is negative 3, since that's what's next to the x, and that the y-intercept is negative 0, negative 2. Okay, so all we're going to do is put a point on 0, negative 2, and I'm going to count up and over with a slope of negative 3. So that'd be down 3 over 1 or up 3 to the left 1. Since the inequality is also equal to, this is going to be a solid line, and it says y is less than, and what you're looking for there is which side of the line is the y's decreasing, and that would be down in this area here. So when it's y is less than, you want to shade toward the negative y's, and so that's this whole area over here. Okay, so if we picked a point anywhere on here, so like let's say we pick this point, anywhere in this shaded region, when we plug it into our inequality, we should get a true statement. So our y value there at negative 5, 0 is 0, and we would have 0 being less than or equal to negative 2 minus 3 times negative 5. So we're saying, is 0 less than or equal to negative 2 plus 15? And sure enough, 0 is less than 13. So we know that that is the area that contains the solution set. So here's our other example, and again, you want to start off just by solving for y. So I'm going to subtract 10 to the 10x to both sides. And that will be negative 4y being less than negative 16 minus 10x. And then I'm going to divide everything by negative 4. And so that's going to leave us with a positive 4 and a positive, I'm going to reduce it to 5 halves x. And since we divided by a negative here, we're going to flip our inequality sign to being greater than. So we already have the inequality solved for y. You can tell now that the slope is a positive 5 over 2, and the y-intercept is 0, 4. And so we're just going to plot these, starting the y-intercept at 0, 4, and then counting up 5 to the right 2. Or down 5 to the left 2. Now the inequality is not equal to. All we have is this greater than sign, so that means it's going to be a dotted line. And it says y is greater than, and so you're looking for where the y values are going higher and higher, which is up here. Okay, so it's very easy to check the solution. I'm going to use the same coordinate because it looks like it's in the same, it's in the shaded area again. So I'm going to test the coordinate negative 5, 0. The y value is 0. So you're asking, is 0 greater than 4 plus 5 over 2 times negative 5. (25/2) is negative 12.5. And so sure enough, 0 is bigger than negative 8.5. So we know that that is the correct area for our solution.